So, do you remember sitting at your desk, a sheet of maybe 100 math problems right in front of you, a giant timer ticking down on the chalkboard, and your heart is just pounding? If you're like most people, that memory of timed math tests probably brings up, well, at least a little bit of stress. Well, welcome to this explainer. Today, we're looking at some fascinating research from the book Teaching Student-Centered Mathematics to show you a much better, research-backed way to learn basic math facts. And spoiler alert, it moves completely beyond that old-school rote memorization.
Okay, let's dive into this. For decades, math education heavily relied on flashcards, time drills, and just blind memorization. We were basically told to sit down and stare at the facts until we knew them cold. But this outdated approach caused completely unnecessary anxiety for so many of us, and honestly, it entirely missed the point of what mathematics actually is. It turns out, forcing kids to just memorize isn't only stressful, it's highly ineffective.
Think about it this way. If you try to teach through pure memorization, you are asking a student to memorize over 300 isolated math facts. You've got 100 addition facts, 100 multiplication facts, plus all the corresponding subtraction and division stuff. Expecting a young learner to just rote memorize over 300 separate, disconnected pieces of information is a massive cognitive load. And when they forget just one under the pressure of a test, they have absolutely no backup plan. They just freeze.
Arthur Baruti, a really prominent mathematics researcher, points out three major limitations to this pure memorization approach. First, it's incredibly inefficient. As we just saw, there are simply way too many facts to memorize. Second, it leads to inappropriate applications. Basically, students misapply facts because they don't actually understand the underlying numbers, meaning they don't even know how to check their work to see if it makes sense. And third, it causes inflexibility. When struggling learners get trapped in this endless memorization loop, they never develop flexible strategies. It doesn't build their skills at all. It actively prevents them from developing higher-level mathematical thinking.
So, here is the roadmap for our explainer today. We're covering the rote memorization trap, Phase 1, counting, Phase 2, reasoning, Phase 3, mastery, and finally, number sense.
Let's start with Phase 1, counting strategies. This is where every single student begins their mathematical journey, and it's a perfectly normal, absolutely necessary starting point for young learners. In Phase 1, students use object counting, like physical blocks or counting on their fingers. Or they use verbal counting to figure out an answer. For example, if you give a Phase 1 student the problem 4 plus 7, they generally won't just instantly know the answer. Instead, they might start at 7 and verbally count up by ones, 8, 9, 10, 11. It gets the job done. But as numbers get bigger, counting by ones becomes incredibly slow and very prone to errors. They need a bridge to get away from counting by ones.
Phase 2, reasoning strategies. Now, what's really interesting about this slide is how it changes the whole game.
This is the absolute most critical phase in a child's mathematical development. And sadly, it is exactly where a lot of traditional curriculums fall completely short because they try to just skip right over it. Phase 2 is all about using known information to logically determine an unknown combination. Instead of treating every single math fact as an isolated island of information, students start connecting what they already know to what they don't know. This relational thinking, it's actually the secret sauce used in a lot of high-performing countries around the world. They don't drill more, they explicitly teach kids how to reason through the numbers.
Let's look at a concrete comparison, so you can see just how powerful this is. Imagine giving a student the problem 6 times 6. A student stuck in Phase 1 is going to try to count up by ones, or maybe they'll try to draw 6 groups of 6 little dots and count them one by one. It takes forever, right? But a Phase 2 student, they use logic. They think, well, I already know my 5 times tables, so 6 times 5 is 30. Therefore, one more group of 6 makes 36. Do you see the difference there? It's highly logical, highly connected thinking.
Let's look at how this works in practice. For facts with a 4, a student can use the double and double again strategy. If you need 4 times 6, you just double 6 to get 12, and then double 12 to get 24. Boom, done. Or, to figure out 6 times 7, you can use the add one more set strategy. 5 sevens is 35, plus one more 7 is 42. We aren't asking them to guess here, we are giving them visual, concrete tools to break these numbers apart.
Teachers and parents can actually explicitly teach these incredibly powerful Phase 2 strategies, things like
combinations of 10 using a 10 frame, or the making 10 strategy to bridge numbers. There's also take from 10 for subtraction and decomposing a factor for multiplication. By explicitly teaching these methods, we're helping kids break numbers apart rather than blindly memorizing them. And with a bit of practice, these strategies become so incredibly fast that they happen almost instantly in the child's mind.
Phase 3. Achieving mastery. Let's move to and see how this builds into the final stage.
This is the final developmental phase, the ultimate goal where things become truly automatic. The definition of mastery here is producing answers efficiently, fast, and accurately, usually in about 3 to 5 seconds, without resorting to inefficient means like counting on fingers. But here is the massive paradigm shift we really need to understand. Mastery is not defined as mindless recall. It is the natural, rapid byproduct of having strongly developed those phase 2 reasoning strategies. They just process the logic so incredibly fast that it looks to us like they've memorized it.
So mastery is achieved through repeated experiences with reasoning strategies, not isolated drill. Handing a kid a stack of basic flashcards just won't help them if they don't have the reasoning strategies down first. What works instead? Collaborative games. Engaging math games and activities that infuse reasoning are highly effective because they encourage kids to flexibly select strategies in a low-stress, really fun environment. When they're having fun and collaborating, the facts just naturally commit to memory.
Number sense over memorization. This brings us to the overarching takeaway of this entire explainer, the profound, foundational importance of number sense. Research shows us that early number sense predicts school mathematics success more than other measures of cognition, like verbal, spatial, or memory skills. That is a stunning finding. Think about that. Memory skills don't predict math success. Number sense does. So the crucial point is exactly why shifting away from rote memorization and toward relational reasoning is absolutely vital for setting students up for long-term success. To put it simply, number sense is flexibly thinking about numbers and their relationships. When a student has strong number sense, they can compose and decompose numbers at will. If they forget a standard algorithm, this flexibility totally prevents them from making those common, systematic errors we see so often. They can estimate, they can check their work for reasonableness, and they can even invent their own computational strategies. They are completely in control of the math.
True mathematical fluency means being able to flexibly, accurately, efficiently, and appropriately solve problems. It's not at all about being a human calculator who can just regurgitate a number on command. True fluency empowers students. It fundamentally reduces their anxiety because they know they have multiple ways to solve a single problem. And importantly, this relational thinking forms the exact foundation they're going to need for higher-level algebra and advanced mathematics later on.
Which leaves us with this final thought to consider. If we want to build confident problem solvers, isn't it time we stop making kids memorize and start helping them reason? The next time you're helping a student with math, try putting away the flashcards and instead ask them, how can we figure this out using what you already know? Thank you so much for joining me for this explainer. Keep questioning, keep reasoning, and I'll see you next time.